Welcome, everyone. Good afternoon. I believe we can start our sessions. Thank you for joining us today. Thank you. Yes, we have a great session today organized with our partners from eBalance Plus project from Horizon 2020. So let's start without wasting some time. So thank you for joining us today. So let me first introduce myself and my colleagues. Okay. Can you see my screen now? Okay, great. So this is Dilara Göker. I am the research director at Reengen. We are a SME company from Turkey. And today I'm not only representing Reengen, but I'm also representing eBalance Plus project with all our partners here. So today we are focused, this will be our first webinar of a series organized by the eBalance Plus project. And our project has received funding from the EU Horizon 2020 Innovation Program. And today's webinar is focusing on innovations to increase demand-side flexibility in the distribution grid. So my colleagues are Jacobo Peralta from SEMOSA, coordinator of eBalance Plus project. Thank you, Jacobo, joining us today. And Ms. Anna Pinarella, assistant professor of electric power systems from University of Calabria, Italy. She's also a partner in the eBalance Plus project and will talk further about their contributions. And Mr. Pascal Viza, Pascal is also a researcher from the University of Calabria from Italy. And Doğukan Acı is a research specialist from Reengen. So today we want to talk briefly, introduce about our project and about the innovations to increase demand-side flexibility in the distribution grid. And this is actually more on the smart energy transition in Europe. So we are focusing on this topic and we are addressing innovation solutions. So we want to give you a brief introduction to our project and about our innovative technology solutions in the project. So to start with, if we would like to see why we are focusing on this project, it is the energy perspective from Horizon 2020 and now Horizon Europe. So we are focusing on secure, clean, and efficient energy and the relation of energy transition on climate neutrality. Because we see EU has set to drive the energy transition, and energy transition in EU takes center stage and cast for climate neutrality. And Horizon Europe and Horizon 2020 framework programs are both focusing on a climate neutral Europe. And so our research and innovation projects and our innovation actions are addressing such energy transition actions. And right now, with the energy systems are becoming increasingly interlinked, and with the international and innovation actions gain more and more importance, because with the rising of renewable systems, with the change of behavior of consumption, we have to bring innovative solutions to address energy and climate issues. So today we are focusing on different parts of it, but mostly on the energy grid transformation and digital feature of it. And by this, we are addressing data science, we are addressing platforms, we are addressing energy measurement and demand response management. We are addressing smart grids technologies. So we are developing these technologies actually to be able to create a smart grid system, to be able to have the smart energy system to address climate costs in general, we can say. So just a brief introduction, who we are. As Riangen, we are providing cloud-based energy and sustainability intelligence solutions for buildings, facilities, and utilities. But we are also providing such digital energy intelligence solutions and connectivity solutions for eBalance Plus as well. So today, we are focusing on our solution within the eBalance Plus project. Thank you very much. So I would like to give floor to our next panelist, Jacobo Peralta, our project coordinator. Jacobo, if you're ready. Thank you very much.
Thank you very much, Dilara, for your presentation, my introduction. Let me share my screen to introduce the project.
And while you're sharing your screen, maybe we can also interact with our audience, and we can share a poll of questions to introduce each other, let's say, because we are introducing ourselves as panelists, but we also would like to get to know our audience profile. So if you can just quickly answer 2 questions, that would be great. We can continue in like in a minute. I see our audience already answering the questions. So okay, Jacobo, please continue with your presentation. Thank you for your patience.
Thank you very much. So I guess that you can see my screen, and I hopefully in full screen mode. Yes. My name is Jacobo Peralta. As Dilara has presented me, I'm the project coordinator of eBalance Plus and project manager in Somoza. But this is a Spanish company, engineering company located in different places in Spain, but mainly in Malaga, in the south of Spain. Okay, I would like to tell you the story behind eBalance Plus. As Dilara has introduced, eBalance Plus is our Horizon 2020 project that started in February 2020. As you can imagine, it was a little bit hard at the beginning of the pandemic. But the previous phase was the eBalance project that finalized their activities in 2017. And in this project, we were focused on the residential side. This is one of the differences in our projects. And we focus on controlling the smart home appliances in a residential resort in the Netherlands. That was our demo site. In this demo site, we focus on, we addressed controlling the smart home appliances that were, as you can see in the screen, dryers, washing machines, and PV inverters. We control to control the demands according to the grid parameters in order to support DSO in the normal electric operation of the grid. As this demo site was a microgrid, the DSO was a high interest to increase the resilience of this place. This was the idea that we developed in the previous project was to flatten the power profile at the grid level according to the DSO instruction, and we addressed 34 cottages. So our algorithms will be running at the grid level and at the hub level, trying to control all the smart home appliances deployed in these places. So in the first step, our system were able to predict the schedule of the different appliances. And in the second step, as you can see here, our algorithm were able to move the schedule of the different appliances in order to avoid high energy consumption or low energy production from the PV panels, with the general goal of flattening the electric grid profile to support the grid operation and to avoid congestion, avoid extra energy consumption from the distribution of the electricity, and other parameters related to the energy efficiency of electric grids. So this was the focus on the previous project, and in Balance Plus, we are using the same platform, but in order to test new solutions, new algorithms, and other kind of technologies that are able to increase the flexibility of energy grids. The first project proposed, and this is the same approach that we are following, a fractal layer and hierarchical architecture in which is composed by management units that are basically hardware that is deployed in the different domains levels, in the customer domain, distribution domain, and transmission domain. And every unit control using this hierarchical structure of the electric grid, the units behind them. In this way, we can provide a bidirectional communication between all the points in the electric grid, and we can deploy algorithms that can balance the energy in every point independently. The idea of this hierarchical approach is that it's totally scalable because it's using the same structure as the electric grid, and it's totally replicable because this structure is common in all the regulation and framework and countries in Europe. So we are following standard approaches, and we are using the same electric grid structure to roll out our solutions. The main difference between our first project, eBalance, and the new one, eBalance Plus, is that in this case, it's not only the objective to flatten the energy profile, but we need to increase to prepare the flexibility of the customer level and grid level to new actors like the energy aggregators, like active DSO participating in local flexibility markets, and other stakeholders that can be interested in participating in this kind of solution in the future. And in the latest but not the least, the increase the resilience, for example, in microgrids or supporting with the storage system and so on. For this reason, in our project, we would like to test new technologies like power inverters based on silicon carbide, new prediction algorithms, new management units able to run more sophisticated algorithms, storage that will be at building or at district level, vehicle to grid charging points, and IoT devices. That this is one of the technologies that we will see today in our workshop. Other difference between the previous one and the current one is that we have, in this case, 4 demo countries in order to test different framework technologies that are located in Spain, Italy, Denmark, and France. And not only we are going to test residential services, but we are focused also in the tertiary sector, extending the approach and the scope of the previous one. And of course, the last point is to address new business model for DSOs, aggregator, thinking on new local flexibility markets and trying to provide new solutions for ancillary services and this is possible for distribution energy resources based on DC power. So that's all of my brief introduction. Thank you for your attention. And of course, if you have any comment, don't hesitate to contact me. Thank you very much.
Thank you, Jacobo. Yes, our audience can either share their questions on the Q&A section of the Zoom below, or of course, you can always contact us via email after the session as well. So maybe now it is great to hear the introduction to the project from our project coordinator, and what are the great solutions we are developing and planning to test in different demo sites. So one of those demo providers and a strong partner in the project, University of Calabria. So Miss Anna Pinarelli, if you're ready, can we hear your presentation?
Thank you, Dilara.
Thank you.
I'm sharing my screen. Okay, do you see my screen? Okay, and presentation. Okay.
Right now we are seeing in the presenter
Okay,
mode.
okay, thanks.
Yeah.
One moment, please. I'm changing the screen because we have. Okay. Now it's correct?
Yes.
Okay.
Perfect. Thank you.
Thanks. Good afternoon, everyone. My presentation is about one of the demo site of a Balance Plus project, in particular at the University of Calabria. The University of Calabria, in particular the campus, consists of several buildings in terms of laboratories, office, residence, library, and so on, that represent natural consumers in terms of electrical and thermal loads. We have a particular distribution supply in terms of one primary substation, medium voltage, and 28 secondary substation. We have also several renewable energy generation plants that are operating. In particular, we have for 40 rooftop of office buildings PV plants, and we have also one geothermal plant and 2 solar concentration plants and 1 microcogenerator plant. Some buildings and plants have been equipped with monitoring and control system, and so the campus of the University of Calabria can be considered a natural energy community, because it is an aggregation of consumers, prosumers, and producers. In particular, for a Balance Plus project, the infrastructure that will be involved as a demo site are the primary substation, the 4 secondary substation, 4 office buildings, and 5 apartments of the Monaci Residential Center. Also, will be involved an experimental microgrid that consists of 2 PV plants, commercial PV plants, 1 ceiling and drying microcogenerator, a commercial lithium battery energy storage, and several electrical controllable and non-controllable loads. The scope of University of Calabria demo site and a Balance Plus project is to increase the energy flexibility of buildings in terms of consumption through the use of IoT devices, smart appliances, so in order to enable demand response program, and also in terms of generation by the photovoltaic power modulation and modulation. Other goals is to deploy the resilience service and increase the grid reliability, so to support the distribution system operator or transmission system operator service, because the particularly configuration of the distribution supply of university of the campus represents an equivalent part of conventional distribution grid. Other scope is to simulate and test the benefits of a demand response service to manage the energy flexibility resources, and finally also to test smart grid automation and control technologies to unlock the availability flexibility. In particular, we have been installed and will be install the technological solution implemented in a Balance Plus project, and also the model and algorithms implemented in this project to improve the control and the automation and communication for the primary substation and the secondary substation, so to support the DSO or an aggregator, to enable the improve the management of flexibility of PV plant, and also to increase the flexibility offered by the office building using smart storage system. And also to test the demand response program and evaluate the responsiveness of the end users using IoT devices, small smart storage that will be installed in each apartment, and also by web application. All these technological solution will be integrated and so to realize an energy management system by the Balance Plus platform. Naturally, this is the principal scope of the University of Calabria campus, that is to control, to monitor the consumption and the generation, to evaluate the flexibility of this energy community, natural energy community, and so to maximize the self-consumption of this energy community, so to reduce the CO2 emission, and also to support providing ancillary services for a DSO or aggregator. That's all for my side, briefly. Thank you for your attention. For more information, you can contact me and my colleague Pasquale Vizza by email. Thanks, Dilara.
Thank you very much, Anna. And Calabria looks beautiful on the pictures.
Thanks.
Yeah, thank you for this great presentation. So now we heard about our project scope, and we heard about our project purpose, and we learned about our demonstration site. So if Anna, yes, so maybe right now it will be great also to hear our solution, like what we will work, what are we working on developing within the Balance Plus project, and how we can utilize such solution for the demo site requirements. Because Anna mentioned very briefly, but very greatly that there is a natural energy community within the campus with consumption, with production, so with different layers of management units for a smart electricity management, with opportunities to create flexibility for the grid. So right now we are addressing these development solutions. So now I am passing the mic to my colleague Doğukan from Rengen. So he is going to present our research development for the purpose of the project. Thank you. Yes, we can see your screen, and thank you, Doğukan.
Yeah, okay. Thank you, Dilara. Good afternoon, everyone. This is Doğukan from Rengen. I'm the R&D project specialist in my team. And also, in this presentation, I would like to mention about our contribution as a partner in eBalance Plus platform, eBalance Plus project. Yeah. As Jacobo mentioned, the main aim of the eBalance Plus project is creating flexibility for next generation low carbon smart grid. And also in the project, we create a flexibility mechanism between different stakeholders and utilizing different source of flexibility. As a Rengen, we are focusing on flexibility at the bottom level. The bottom level is the consumers as normal persons, electricity energy users. In consumption side, there is a huge potential and flexibility resource coming from end users. And we need to utilize this flexibility reserve by using smart ICT technologies, but there is a problem. The normal electricity users like us, we just want to use electricity as a usual. We couldn't relation between our consumption, our behavior, and the results of the grid side. That's why the project, one other project aims is the end user engagement for the flexibility use cases. And I would like to present our experiences for creating a mobile app directly focused on the end users and creating a flexibility reserve between end users. And there are some steps for developing a mobile app I would like to mention also. The first thing to create a mobile app, the first thing we do is investigating the needs of the end users. We need to understand what they need and what is motivated for them. And our major source is one of the deliverables of the project coming from our Polish partners, IPI. There is a sophisticated survey and research between 4,000 people from 4 different countries, and they give us very valuable actionable insights for the development side. And when we look at what is the motivation for action for the end users, 2 things are coming from. The first thing is the first motivation behind the energy efficiency and flexibility is reduction of the expenses, the major, most dominant part of the research. And also the first thing that makes persons mostly demotivated is low return of the effort and investments. They're changing habits or some investments. So we need to savings and their results of the behavioral changes. And also, another problem we see that we need to create an awareness, a literacy, and give information about what is energy flexibility, how can we save energy, and also so on. After from research, we also create a research from as a competitor analytics. There are several solutions in the market. Some of them are EV charging solutions. Some of them are home energy management solution, but only for the energy saving. We create a competitor analytics and combine with good practices for our research. Our competitor analytics includes energy consumption analytics sites, home energy management, smart EV charging solutions, and also demand response for the bottom level. And after all kind of analytics, our product team with the project partners create a mock-up designs for the mobile application. Our mobile application serve flexibility, efficiency, calculations, and also energy literacy for the end users. In the mobile app, users give some actionable insights and literacy, as you can see in the last part. We can give some details about how to create energy flexibility as a normal person. And also, by using IoT device and sophisticated algorithms, we create some actionable insights and visualizations for their usage with their energy consumption, usage behaviors, flexibility reserves, and so on. And also giving them a energy performance with their savings to give them their results of the actions. And this is the front-end site, the most beautiful site also. And it is not that easy to create good visualizations and graphs. There is also backend site, and in this stage of the project, we create product feature requirements for the mobile app development with our partners. Our mobile app and our solution in the project are really depends on different kind of stakeholders, different kind of technologies, and we need to combine this solution. For instance, the creating baselines for the energy flexibility, there are several data sources coming from IoT device, coming from sophisticated algorithm results, and also third-party integration and service integrations. And also there are some data calculations as well. And in this stage, in the implementation side, we are going with the algorithms and also development efforts. That's all for me. I would like to thank you for your attention, and I would like to give greetings from Rengen team. For more information, you can contact us for my email and also our colleague as well. Thank you.
Thank you, Dorkan. I see there are many development efforts. So hopefully we can actually combine our efforts to bring a great solution within the project. So, well, we heard about the campus and we heard about the flexibility solution, and we have a question from the Q&A section. And I also, by this means, I would like to remind our audience about the Q&A section. You can share your questions there. So the question is, will the developed flexibility applications be implemented only on campuses? Is there any other potential implementation fields? So for this question, maybe I can start, but I can also pass the mic to other panelists as well. So I can say that for eBalance Plus project, as Jacobo also briefly mentioned, we have different university campuses participating within the project for sure. But these flexibility solutions, okay, like we are focusing on the IoT management in buildings, mostly for today for demand response. But there are several other solutions for residential cases, it can also be implemented on office buildings. There are the flexibility applications for electrical vehicles or storage systems. So like we are validating our developments on university campuses, mostly for within the project, but these campus buildings actually represent energy communities, as also Anna mentioned. So this can, of course, be also replicated and hopefully address a wider energy transition within the European energy communities. I can say that. So would you like to add a few words for the questions? Anna, do you agree? So what we validate within the campuses, do you think we can also other potential implementation fields for flexibility applications?
How I have said before, the buildings, the office are equivalent of other sector in terms of residential sector, industrial sector. Naturally, the industrial process is a particular application, but the model, the algorithms is the same because change only the consumption profile, but the production profile, the use of smart storage is total equivalent in residential sector, industrial sector, and so on. Change only the consumption profile, and our algorithms, the models that are very sophisticated, is very robust in terms of output. Also changed the consumption profile because the consumption profile is an input of this model of this hardware.
Yes, exactly. We are addressing an optimization solution somehow between consumption, production, and other parameters of the energy, like electricity grid equation, let's say, this complex equation, and somehow try to give this optimized solution for different stakeholders. This could be an end user, this could be a facility manager, or this could be an aggregator, a DSO. So we know the electric system is kind of different stakeholders. So we can utilize this solution in different, let's say, market dynamics for various scenarios. So do any of the other panelists, would you like to add a few words on that? Okay, we're great. So maybe we can bring our second poll. So it's time to ask our audience the questions, the vice versa version. So which of the solutions would you be more interested and what you see as the main challenges to implement ICT solutions in your business context? And do you have any assumptions on the market reach of these technologies? Let's give a couple of minutes to our audience to answer the questions. And in the meantime, we have another questions. Yeah, that's again related to the flexibility achieved in campuses. So maybe now we can focus on the second question before passing to Pascal's presentation. I'm sure this answering this question might also give some spoilers to the presentation. But the question is how flexibility can be achieved in the campuses? Which devices are taken into account? So yeah, I see there are two ways of answering this question, because the devices taken into account for flexibility solution, well, for this demand response part, there are different solutions. So maybe if Jacobo, could you please share some samples of the, let's say, devices we take into control, like what kind of devices we take when we address the flexibility in campuses within this project.
Thank you. I think that Anna has explained very well. Campuses is like an energy community. That means that it's composed by different buildings, different facilities that all together are working like a community, because not all the buildings has the same facility, not all the buildings has the same use. So the idea of e-balance in the context of campuses is that we are addressing different facilities like electric batteries, like PV system, like HVAC system, because depending on the building, we can find, for example, ventilation or only air conditioning or only heating, or different combination of HVAC system that makes even more complex the estimation of flexibility, and in the same time, the management of everything. So the campuses brings us a very good opportunity to test different use cases with different combinations, with different algorithms, and the high challenge is to estimate this flexibility, and at the end, to manage this flexibility to develop the services that we are explaining today, like services for DSO, aggregator, new stakeholders that is expecting that come to the market in the future.
Thank you very much. Well, yes, as you also mentioned, like we are like covering different, let's say, groups of devices. If you're mentioning consumption, that will include like heating, ventilation, and cooling systems. That will include appliances. That will include other, let's say, lighting and other sources of consumption. And we have like for the other use cases of the project, we have electrical vehicles, and we have different storage, different level storage systems. So there are many energy systems and many monitoring and controlling devices that can be used within this, let's say, infrastructure to address flexibility solutions. So maybe also to better understand how we approach devices on the campus demonstration, it's better to pass the mic to Pascal now. So he will explain us better about the demonstration case in Calabria and how we can utilize such technology in the use case for the eBalance Plus solution.
Thank you, Dilara. Okay, I will share my screen. Oh, no. Okay.
Yes.
You see the screen?
Yes.
Okay, perfect. Okay, I'm Pasquale Vizza from University of Calabria, and this afternoon I will share with you some of the IoT solution that will be installed at the University of Calabria for the implementation of the demonstrator for the Balance Plus project. So I will share to you some of the solution, the possible functions, and how IoT solution can be used to engage the users. As explained before from Anna and other, the University of Calabria demo consists in many structure and buildings that are involved to implement this demo. But in this presentation, I will focus on a residential complex of the same university, one of the residential complexes of the same university, named Monaci. Monaci is a complex building with about more than 100 of apartments. And for the demo, we have chosen 5 apartments that are similar one each other, but they have different exposure. In each apartment, we have 2 bedrooms for 2 students, 1 sitting room, a kitchen, and a bathroom. For each apartment, systems. In particular, for each apartment, we will install the Ampere smart storage system that is provided by the company Ampere, that is a partner of the same project. And it has a capacity about 3 kilowatt hour. We already have installed the smart meters to monitor the power consumption of the same apartments. Meter has 3 lines, so it can monitor 3 power lines. At the same time, we can monitor the single load using single smart meter for the single load, for example, using smart plugs. So here in the slide, we can see a floor plan of the apartments, of the different apartments. And for each apartment, we will install, as I have said, we will install the smart appliances that can be pumps, smart washing machine, smart dishwasher, and so on. And also we will install the IoT devices that can be smart thermometer, smart plugs, light sensor, and window sensor, and so on. The main aims of IoT devices and smart appliances is to provide the power and energy flexibility, and also their other function. The second function is to reduce consumption and also to energy for the energy savings. To integrate these IoT devices and smart appliances, it is necessary to make available to make the IoT devices and the smart appliances to interface one each other, to interact the IoT devices with the smart appliances, and vice versa. So to allow monitoring aspect, and also for the actuation aspect. So the main function, as I have said, is to provide flexibility, but at the same time, it's necessary to monitor the loads or to evaluate if possible flexibility action are possible. For example, direct controlling or provide advice to the user. For example, using the mobile application, as Lokan said before. At the same time, such devices are useful to engage the same user of the apartment. User that in this case are students, but they can, for other apartment, can be also other simple users, not for not necessarily students. So starting from this function, we can go for the different IoT devices, and we can see what kind of function they can provide. For example, if we consider a smart thermometer, it is necessary, for example, to it is useful to, for example, evaluate in real time if there is the necessity to intervene, for example, to modify the configuration of the conditioning system of the pumps, or for example, directly controlling, or to send an alert to the user using the mobile application. At the same time, using the smart thermometer, the setting temperature, the aggregator, using also the algorithms, it's possible to evaluate if it is possible to intervene to provide flexibility services to the grid, modifying the power consumed by the conditioning system or other. We can also provide through the monitoring phase an evaluation of, for example, to evaluate the behavior of the user, to reduce the energy consumption, or to through new algorithms to obtain different configuration for conditionate the rooms. So also, if we consider the Windows sensor, it's possible, for example, to send the alerts to the users, or, for example, to direct controlling the heat pumps if they are present and installed, or to control them, reducing the power consumption, and also we can carry out the evaluation for the user behavior. So at the same time, for this smart plugs, if we have loads that are not smart, we can control with the smart plugs the on-off of these loads. We can measure the consumption, the power consumption of these loads, and make the user aware of this power consumption. So it is useful both to engage the user and also to evaluate if it's possible to require flexibility action. At the same time, so if you consider the light sensors, if it's possible, we can send it to the user an alert to reduce their consumption, or, for example, to send many alerts, and then we can switching off the light if the user don't intervene. So after evaluated these smart devices with these IoT devices, we can use such devices to engage the users. In particular, we can use two particular tools, in particular the monitoring infrastructure and the mobile application. But we have to consider three particular aspects that are the economic and financial aspect. So it is important, for example, if we consider the economic aspect, to highlight the users that with their operation they can obtain financial or economic savings. We can inform the users that with their operation they can obtain social aspect. That, for example, they can reduce the CO2 emission, and also you can evaluate to use the challenge among the users, or for the same users. For example, that the user, one user is doing better than another user, and so on. So that's all from my side. Thank you for your attention. So if you have any question, we are available.
Thank you very much, Pascal.
Thank you.
Well, it was really nice to hear how we can engage users and how we can utilize IoT to like optimize and use consumption, and also how we can address this for the flexibility approaches. We had also had some questions on the Q&A section. Thank you, Jacobo, for answering those online because we're almost out of time. In summary, we can say that we are developing such technological innovation solutions, but these solutions can partly be utilized by different stakeholders, as we mentioned previously. This can be utilized by facility managers. This can be used by the homeowners, even like the residential users, but also this can be also very beneficial for the DSOs. So this is the end of our session, but before we close, we would like to hear if you are interested in contacting us in general, because we represented different solutions today. And also this was our first of many webinars for the eBalance Plus project. So which eBalance Plus technologies are you interested in for our next events? If you can choose that, that will be great for planning our next webinar. So I would like to thank again to all of our panelists and all of our audience for their patience and contributions to our webinar. I think this was a really good introduction to our project and solutions. And hopefully, like, our project is still ongoing. Our project is very active. In the coming period of the project, we are planning to present other parts of the solutions and also results and outcomes of our projects for further developments. So thank you very much.